Alright, we have to begin with mental arithmetic part B. But just prior to that, we have to practice our cubes. Okay, so the first 10. Forwards and backwards. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. 1, 8, 27, 64, not fast enough. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. 1, 8, 27, 64, 125, 216, 343, 512, 729, 1000. And backwards. 1729, 512, 343, 216, 125, 64, 27, 8, 1. And again. 1729, 512, 343, 216, 125, 64, 27, 8, 1. And again, 1729, 512, 343, 216, 125, 64, 27, 8, 1. And now, the next cluster of 5 that I've been working on. 11 cubed, 1331. 12 cubed, 1728. 13 cubed, 2197. 14 cubed, 2744. 15 cubed, 3375. And forwards by pack. 1331, 1728, 2197, 2744, 3375. And again, 1331, 1728, 2197, 2744, 3375. And backwards. 3375, 2744, 2197, 1728, 1331. And again, 3375, 2744, 2197, 1728, 1331. And by digits. 1331, 1728, 2197, 2744, 3375. And again, 1331, 1728, 2197, 2744, 3375. And backwards. 3375, 2744, 2197, 1728, 1331. And again, 3375, 2744. Is that right? Let me try that again. 3375, 2744, 2197, 1728, 1331. Alright. And now let's just make sure. $17 cubed is 4,913. 4,913. 4,096. 4,913. 18 cubed is 5,832. 4,096, 4,913, 5,832. Alright, 3 times. 4,096, 4,913, 5,832. And again, 4,096, 4,913, 5,832. And again, 4,096, 4,913, 5,832. And 19 cubed. 6,859. 6,859. 6,859. 5832. 6859. Alright. Okay. 4,096. 4,913. 5,832. 6,859. And again. 4,096. 4,913. 5,832, 6,859, and again, 4,096, 4,913, 5,832, 6,859. Okay. Alright, now the whole set, 3 times, forwards and backwards. 1,331, 1,728, 2,197, 2,744, 3,375, 4,096, 4,913, 5,832, 6,859, and again 1,331, 1,728, 2,197, 2,744, 3,375, 4,096, 4,913, 5,832, 6,859, 8,000, 20, and the third time. 1,331, 1,728, 2,197, 2,744, 3,375, 4,096, 4,913, 5,839, no, 5,832, 6,859, 8,000. And now by digits. Okay. 1331, 1728, 2197, 2744, 3375, 4096, 4913, 5832, 6859, 8000. And again, 1331, 1728, 2197, 2744, 3375, 4096, 4913, 5832, 6859, 8000. All right. Do that again later today. But for now, the arithmetic. Okay, so write 9/40 as a decimal. Alright, let's see now. 1/40 is 0.025. So 9/40 must be 0.225. 13/80 as a decimal. Okay. 0.1625. Which of 21 over 56, 15 over 48, and 11 over 35 terminate? That would be 15 over 48. No, wait. Actually, none of them do. None of them terminate. Right, 7,007 over 1,250 as a decimal. Okay, Well, that would be 56 over 10,000. And that would be 0.0056. Write 33 over 120 as a decimal, or state that it does not terminate. Cancel by 3, so we have 11 over 40. And 11 over 40 does terminate. 11 over 40 does terminate. Zero point 275. 0.275. Write 0. Recurring 27 as a fraction in its lowest terms. So that's 27 over 99, which is 9 over 33, which is 3 over 11. Write 0. Recurring 135 as a fraction in its lowest terms. That's 135 over 999. Which is 15 over 111, which is 5 over 37. Write 0. Recurring 594 as a fraction in its lowest terms. That's 594 over 999. Which is 66 over 111. Which is 22 over 37. Write 0. Recurring 0027 as a fraction in its lowest terms. That's 27 over 9999, which is 3 over 1111, which cannot be reduced. Write 0. Recurring 238095 as a fraction in its lowest terms. So we write 238095 over 999, 999. and then we divide through by 9. To get 266. Two six six five five, 26655, and then we have to reduce this by 3. So we get 37037 on the denominator. And 8885 on the numerator. And that's as far as you can go. So next up, we have to work on our working memory. Okay. So chapter 1. Six x to the 5 times 4x to the minus 2, all divided by 8x to the 4. So 3x to the minus 1. So 6x to the 5 times 4x to the minus 2, all divided by 8x to the 4 is 3x to the minus 1. Given that 2x to the a all to the 3 is 8x to the 12, find a. So a must be 4. If 2x to the a all cubed is 8x to the 12, then a must be 4. Three x squared y all cubed divided by 9x to the 4 y squared. Okay, so we get 27 x to the 6, y to the 3 on the top. So it becomes 3 x squared y, 3x squared y. So we have to simplify 3x squared y, all cubed, divided by 9x to the 4y squared. And we believe it's 3x squared y. And it's recognizing that the denominator is the square of 3x squared y. Evaluate 2 to the 10 times 3 to the 5 all over 6 to the 5. 2 to the 10 times 3 to the 5 all over 6 to the 5. So we recognize that the numerator can be turned into 2 to the 5 times 2 to the 5 times 3 to the 5. And the denominator is still 6 to the 5. 2 to the 5 times 3 to the 5 is 6 to the 5. And thus they cancel. And so we get 2 to the 5 alone, which is 32. We have to evaluate 2 to the 10 times 3 to the 5 all over 6 to the 5. And the answer is 32. Simplify x cubed over 2 all squared times 8 over x to the 4. X cubed over 2 all squared times 8 over x to the 4. We square it. We get x to the 6 over 4. And that has to be multiplied by 8 over x to the 4. So the 8 and 2 cancel to get 4. And we get 4x squared. So we have to simplify x cubed over 2 all squared and multiply that by 8 over x to the 4. And we believe the answer is 4x squared. Expand and simplify x at 3 times x take 2 times x take 4. We multiply x take 2 times x take 4 first to get x squared minus 6x plus 8. Then it's x squared minus 6x plus 8 all times x at 3. So we get x cubed first. then minus 3x squared next. Then minus x next. Then 24. So x cubed minus 3x squared minus x plus 24. So we were told to expand and simplify. X had 3 times x take 2 times x take 4. And we said x cubed take 3x squared take x plus 24. Find the coefficient of x squared in the expansion of 2x take 1 all times 3x squared plus x minus 5. Right? Yeah, that's right. Find the coefficient of x squared in the expansion of 2x take 1 all times 3x squared at x take 5. So we're going to multiply 2x by x and then 1 by 3x squared and put them together and we get 5x squared, and that will be it. The answer is 5 because that's the coefficient. So we were asked for the coefficient of x squared in the expansion of 2x take 1 all times 3x squared plus x minus 5, and we say 5. Expand and simplify 2x at 3 all squared. Take 2x take 3 all squared. We know the x squared terms will cancel out. And we know the constant terms will cancel out as well. So we only need to get the linear terms. And the answer is 24x. So we were asked to expand and simplify 2x at 3 all squared, take 2x take 3 all squared, and we say the answer is 24x. Expand and simplify x at 2 all cubed. X at 2 all cubed. So x at 2 all squared is x squared at 4x at 4. Now times that by x at 2. X cubed at 6x squared at 12x at 8. So we were asked to cube x at 2, and we say x cubed at 6x squared at 12x at 8. Given that 3x plus a times x plus b is identical to 3x squared at 6x at 11. No, that's the other way around. Alright. Given that 3x at a times x at b is identical to 3x squared at 11x at 6. For positive integers a and b, find their sum. Okay, I mean, we simply believe that it's 3x at 2 times x at 3. And therefore their sum is 5. So 3x at a all times x at b is identical to 3x squared at 11x at 6. For positive integers a and b, then we believe their sum is 5. Factorize fully. X to the 4 take 13x squared at 36. Well, we believe the answer is x squared minus 9 times x squared minus 4. And we go further. X at 3 times x take 3 times x at 2 times x take 2. So we were asked to factorize fully x to the 4 take 13x squared plus 36. And we say x at 3 times x take 3 times x at 2 times x take 2. Factorize fully 2x cubed take 5x squared take 12x. Pull out an x. And just do 2x at 3 times x take 4. So factorize fully 2x cubed, take 5x squared, take 12x. So we say x times 2x, take 3. Rather, x times 2x add 3 times x take 4. X take 4. Expand and simplify x squared take 9 all over, x squared add 7x add 12. So x add 3 times x take 3 on the top, and x add 3 times x add 4 on the bottom. Cancel the x add 3's. So we have x take 3 over x add 4. So we were asked to simplify fully x squared take 9 over x squared add 7x add 12. And we believe the answer is x take 3 over x add 4. Now simplify fully x squared, or rather x cubed take 2x squared, take 9x plus 18. Yeah, that's right. X cubed take 2x squared, take 9x plus 18. Okay, so we think that a factor is x minus 2. And we think a factor is x minus 3. And we think a factor is x plus 3. So we had to factorize fully x cubed minus 2x squared. x cubed minus 2x squared minus 9x plus 18. And we say x minus 2 times x minus 3 times x plus 3. Factorize fully 16x to the 4 minus 81. Four x squared minus 9 times 4x squared plus 9. And we go further with the first to get 2x at 3 times 2x take 3. So factorize fully 16x to the 4 minus 81. And we say 2x add 3 times 2x take 3 times 4x squared add 9. Sixteen over 81 to the negative 3/4. The fourth root is 2 over 3. And then cubed, 8 over 27. And then reciprocal, 27 over 8. So simplify fully 16 over 81 to the negative 3 over 4, we say 27 over 8. Eight to the 2/3 times 9 to the negative half times 27 to the 1/3. The first is 4. The next is 1/3. And the last is 3. So it's just 4. So 8 to the 2/3 times 9 to the negative half times 27 to the 1/3 is just 4. Solve x to the negative 3 over 2 equals 8. Okay. Raise both sides to the negative 2 over 3. And we get 1/4. So x to the negative 3 over 2 is 8, and we say that x is 1/4. Two x cubed take root x all over root x in the form ax to the n plus b. Okay, we split it up into 2x cubed over root x. Take root x over root x. And the last fraction turns into just -1. And the first turns into 2x to the 5/2. So it becomes 2x to the 5/2, take 1. So they say simplify 2x cubed, take root x all over root x, and we say 2x to the 5/2, take 1. Evaluate 1/32 to the -2/5, all divided by 2. Okay. The answer is 2. So they say evaluate 1/32 all to the -2/5 and then divide that by 2, and we say the answer is 2. Simplify root 50 at root 18, take root 32. Root 50 is 5√2. Root 18 is 3√2. So it becomes 8√2, take 4√2, which is 4√2. So they say simplify root 50 plus root 18, take root 32, and we say 4√2. Expand and simplify 2√5 at 3 all times. Root 5 take 4. So -2 for the constant part. And -5√5 for the third part. So they say simplify 2√5 at 3 all times. Root 5 take 4, and we say -5√5 -2. Simplify root 12 at root 27 all over root 3. Root 12 is 2√3. Root 27 is 3√3. So 5 root 3 all over root 3 is 5. So they say simplify root 12 at root 27 all over root 3, and we say 5. Expand and simplify 3 take root 2 all squared, take 3 plus root 2 all squared. We know the pair of 9s will cancel. We know that the pair of 2s will cancel. So we have minus 6 root. What's that? It's minus 12 root 2. So expand and simplify 3 minus root 2 all squared minus 3 plus root 2 all squared, and we say minus 12 root 2. Given that root 75 at root 12 is k root 3, find k. Root 75 is 5 root 3. Root 12 is 2 root 3. So put them together and you get 8 root 3, so k is 8. So we were asked, root 75 at root 12 is k root 3, find k, and we say k is 8. Root 2 plus 1 over root 2 minus 1 times the top and the bottom by root 2 plus 1. And down there we get 1, and up there we get 3 plus 2 root 2. So they say simplify root 2 plus 1 over root 2 minus 1. Root 2 plus 1 over root 2 minus 1. And we say 3 plus 2 root 2. Simplify 6 over root 12. So that's 6 over 2 root 3, which is 3 over root 3, which is root 3. So they say simplify 6 over root 12, and we say root 3. Simplify 8 over 3 take root 5, but put it in the form a plus b root 5. Top and bottom times by 3 plus root 5. We'll get 4 on the bottom. 8 and 4 reduced to 2. So it's 2 times 3 out of root 5, which is 6 out of 2 root 5. So simplify fully, 8 over 3 take root 5, and we say 6 plus 2 root 5. Simplify 1 over root 3 take 1, plus 1 over root 3 plus 1. Standard algorithm for fraction addition, and then it becomes on the numerator. Root 3 add 1, add root 3 take 1. So 2 root 3. 2 root 3 on the numerator. And 8 on the denominator, so root 3 over 4. So simplify fully, 1 over root 3 take 1 plus 1 over root 3 plus 1, and we say root 3 over 4. Express root 5 out 2 all over root 5 take 2 in the form a plus b root 5. Top and bottom by root 5 out 2. And it becomes 1 on the base. And so it was simplify fully, root 5 out 2 over root 5 take 2, and we say 9 over 4 root 5. Okay. Now back to set 11. Set 11. Oh, here it is. Sam scores halfway through the second quarter of a match. What fraction of the match remains? Well, 5/8. So Sam scores halfway through the second quarter of a match. What fraction of the match remains? And we say 5/8. Which of the following is equal to the number of seconds in 1/1000th of a minute? And you have to choose between 0.24 and 0.6, 0.024 and 0.06, and also 0.006. 1/1000th of a minute is 0.06 seconds. So we choose option 4. So we were asked which of the following options is closest to 1/1000th of a minute in seconds. And the options were 0.24 and 0.6, and 0.024 and 0.06, and also 0.006. And we say option 4, 0.06. Four positive integers have a mean of 5 and a median of 6. Find the mean of the smallest and the largest. They have a mean of 5 and a median of 6. Okay, so they have a mean of 5, so they must add up to 20. Must add up to 20, and there must be positive integers. Okay. Did you say the median was 6? Yes. Okay. Well, do they have to be different? It doesn't seem so. Okay, so what about 2666? The median of those is 6. And the mean is still 5. and the mean of the smallest and the largest is 4. We're going to try that. So 4 positive integers have a mean of 5 and a median of 6. And what is the mean of the smallest and the largest? And we say 4. What is the minimum number of 5 by 30 rectangles needed to tile a rectangle with sides in the ratio of 4 to 5? Alright, so that's basically 1 by 6 as far as we're concerned. Or is it? Let me see that one again. The minimum number of 5 by 30 rectangles needed to tile a rectangle with sides in the ratio of 4 to 5. Well, if we rotate it, I don't know how to do this one currently. I don't know why, but I can't quite see the answer right now. I mean, I can get an answer, but it's not the minimum. But how do you get the minimum? I don't know. I'll try on a different time. Oh, we're at 70 minutes anyway. Probably have to finish.